place. So Brock University, just to give everybody some context, I guess, if you're not familiar with Brock, a fairly young university, celebrating 60 years this year. Located at UNESCO Biosphere Reserve in Ontario. Of the 22 universities, we're considered a medium-sized university, so just over 19,000 full-time students, and 500 acres and nearly 3 million gross square feet. And as I mentioned, located at UNESCO Biosphere Reserve, and we're about 20 minutes from Niagara Falls, if you're not familiar with the area. Go ahead to the next slide. I'm not going to jump into the details here, but I think what the team's going to talk about with you as we go through these slides quickly is just about kind of a journey, and your sustainability efforts, your retrofits, your goals, wherever you are. It is really part of a journey. What we want to talk about here is what laid the foundation for that, and then of course what you can do to capitalize on all of those small projects. So no matter if you're just starting something, contemplating something, or you're halfway through years of doing something, or you're towards the end, it's all important on the journey, and kind of just sharing where we are. So the next slide, will just quickly, I won't spend too much time on this, about the history, because it's relative to the conversation. There we go. Brock's history. So again, 60 years old this year. Big celebrations this year on reaching our 60th. Very first building was the Schmoen Tower, right on the edge of the Niagara Escarpment. Built there, of course, in farm fields way back when on the edge of the Niagara Escarpment. But when the campus was constructed, there was no natural gas in the area, so it was 100% electric. And one of the original board of trustee founding members was an executive with Hydro One. So we got to some electricity focus there as well. I think we just jump to the next slide. We'll jump back. There we go. So the campus went from about 1964 all the way up to 1990 being 100% electric. And at that time, it was roughly 1.5 million square feet. And through the 80s, of course, with the rise in electricity costs and natural gas now being available on the Niagara Escarpment with the regional building across the street in 1984, the university was deciding to put in some gas-fired boilers to augment this expensive electric heating. Full circle, as we'll get to in a second. But with that, so in 1990, they made a plan to install new natural gas-fired boilers. But instead of that, a new project kind of fell on its lap to do a joint venture with Caterpillar and do the first of the 3516 series engines, which are a reciprocating cogeneration engine. So the 3516A model way back in 1990 were installed in 1992. So we had 3516, so 16-cylinder Caterpillar engines. They produce about 800 kilowatts each and about 1 megawatt worth of heat. So it was designed as a heating plant, and it would heat load follow, and the electricity was a byproduct back in the 90s. We ran those 3516As, that's serial number 1 through 8, had a great partnership with Caterpillar for that. That became the #1 selling reciprocating cogeneration engine in the world. For those who like me, very geeky on that stuff, in Australia, they have 98 of them installed in a row at one particular site. So again, that ran very well with heat load following. And then, of course, as electricity costs went up and natural gas costs plummeted, we ended up running the engines 24/7, producing the majority of our electricity. That was great for a budget savings perspective. But when you look at the carbon impact of that, even though we're recovering heat, we use a lithium bromide absorption chiller, produce cooling with a thermal storage tank. I'll talk about in the next slide. At the end of the day, our carbon footprint per square foot compared to our peers that weren't running cogen engines and, of course, buying cleaner power off the grid, it didn't look good. And with that, we decided to do an upgrade on these engines. They're still critical for resiliency. So we removed 8 as a project called Deep 1. We did Deep District Energy Efficient Project, DEEP. We did phase 1 and phase 2, started in 2016, finished in 2021. I don't want to take too much time away from the team, so I didn't go too deep in these details. But we removed 8 3516As and installed 4 3516H models. And so the H model with Caterpillar now produces 2 megawatts, not 800 kilowatts, and about 1.2 megawatts worth of heat. So much more efficient on electricity. With the SCRs on these units, we cut our NOx emissions by over 85%, cut our carbon emissions by 20%. So that was kind of a phased approach with those. units. And with that project on Deep 2, if you want to go to the next slide, Mary, thank you. We did a few other large components. So again, this is the journey, starting with, I like to refer to it as a circulatory system of the campus with our hot water and chilled water loop system, which we run currently at 180 degrees Fahrenheit. Failed to mention that. The arteries and veins, so to speak. We basically did a heart transplant on the cogen plant with those engines. With that, some of the other organs we looked at replacing. We still have our thermal storage tank, 1 million liters or 400,000 US gallons. We replaced our absorption chiller unit, which is 1,200 tons, which had really difficulty dialing down. So it would take a lot of heat, eats the heat very well, produce good 1,200 tons of cooling. If you try to vary that back to about 600 tons, doing some load following, it performed very poorly. So with this new absorption chiller, we're able to dial it all the way back down to roughly 300 tons reliably and efficiently. Also put a new smart chiller there as well with 4 high efficiency compressors on that, replacing an old centrifugal chiller. With that, that formed the foundation in Deep 1 and Deep 2 to other efficiency upgrades on operating and automating the system. And I think I'm going to hand that over to Mary next on the SCADA system. And then dive right into our latest project, the ECCC project of electrification on the system as well. So Mary, is this one over to you?
Thank you, and apologies. I'm still trying to move to the other screen, but anyways, sorry. I'll just stay there. So with ignition, one of the first things that we did was we realized with the new plant, we needed something that would really work well with it. We didn't have a full SCADA system before. We were using a Johnson control system that was more meant for buildings. It was not industrial grade, and that was something that we wanted to change. We had these great systems that were installed as part of Deep 1 and Deep 2 with all these capacities, but we couldn't really use them to their full potential until we did some work on the data management side too. So we decided to install ignition. We looked at different alternatives, but when it came to both price and what it allowed us to do, ignition turned out to be the best solution. It's very compatible. It likes everything, modular too, and you don't have to pay for every single point. So if your plant changes, if your plant increases, then you have the same amount that you have to pay for fees. You don't have to pay for every single point that you would add. That was a huge advantage. The other advantage is how customizable it is. We have a very unique system. You saw all of the different assets that Scott showed us before. So there was no cookie cutter solution that would really reflect everything that we were doing and everything that we were building on. So we had to start from scratch, and the ability that ignition allowed us to really design that to something customized specifically for Brock's needs, that was huge. And again, compatibility, we have several contractors that can work on it. It's open platform with communication. We have a server that serves for translating different protocols. It's very, very streamlined. So we have really liked it. This next slide shows one of the multiple screens that we have, again, custom built. But this one, the idea was to take into consideration what the operations team needed. They are the ones that would be looking at the system on a regular basis. We wanted something that just at a glance would give a good sense of what the whole system was doing. And this is one of those slides. The biggest innovation on this one, you'll see there is something, this blue button that's underneath is the import schedule. What that means is that we took the ability of load following that the engines have, and then we added a layer of programming in that for the engines to then automatically come on or off after a certain period, so that we would not be running one engine at full blast, because that's not efficient for emissions, for the engine's life, for efficiency. So we were just always balancing so that the engines were always running in the right place of the curve. And all of that is done automatically. And that's something that, as great as the engines are, it was not custom made. for the engines. It's something that we had to build on top of that, but using the capabilities of the engines themselves. So again, that's all because of the SCADA system, but it illustrates some of the possibilities that that opened. For the building automation system, it was also part of the long road that will lead us to where we are today. But we have done significant improvements to the building automation system. We also relied on the Johnson control system, and many of you are familiar with it. It's proprietary, it's very expensive. So we also wanted to walk away from that. So we looked at probably 5 different alternatives, if not more. To remind me, it's a while ago now, but we ended up choosing Niagara Tritium. Again, it's very similar to Ignition in the sense that we have many contractors that can work on it. It's more open. The fees that we have to pay for licenses are not outrageous. And it does provide us a bunch of flexibility to really make it our own. So we can customize it. And make it the best version that we can. It's something that our controls mechanics are very happy with. They have provided feedback. We recreated the standards for these. And here is a small sample of what it looks like. So it's completely different for us before the graphics, the numbers, how easy it was to navigate between the different screens. That has been a significant change, and it's something that in the beginning we were concerned about, just the change. Some of our mechanics, they had the old system for very long, but this system allows us to have better controls, better monitoring, trending, sampling rates. All of those were adjusted as part of this initiative. Again, the idea being we get the right data for what we need. Now I'll pass it on to Drew to talk about the next iteration of what we did with the data.
Okay, so thanks, Mary. So you've heard Scott talk about the engines, and you've heard Mary speak to the SCADA, and you've heard the BAS, but really, like I was looking at our carbon reduction plan and our energy reduction, and the SCADA system. It's based on data trending minute by minute, second by second, and it's giving great information so you can make informed decisions on your day-to-day operation. And then you look at your BAS. You know, BAS is a BAS where you're controlling your building, seeing what the spaces are, set points, and as such. But we really didn't have anything that was tracking energy and how our buildings were using energy usage. So I was trying to figure out how we were going to make it to our carbon reduction goals, which is by 2030 was 75% and reduction from 75%, and then at 2050 carbon neutral. And I was exploring, like, you know, how do we get started? How can we do this? And we co-created this with Blackstone Energy, and it's called BlackPack. And it had a few different parts. It had the public facing dashboards, because how are you supposed to, like, when I would talk to people on campus, and I would say, like, you know, we have a cogeneration plant. We generate our own electricity. From that electricity, we use that byproduct heat. They'd be like, really? I didn't know that. And I was like, well, that's the first problem. Like, if you don't know, how can you participate and how can you contribute? So first off, we thought, you know what, let's see if we can bring up the knowledge of our community so they feel they can participate. So this was one of the tools the mechanisms that we were going to use, the vehicles, was the dashboard. So people this is in our Rankin Family Pavilion building. This is the front lobby of the school. There could be potentially 19,000 people walking by at any given time during the day, looking at this and seeing what facilities management and Brock University is doing towards sustainability and energy reduction. Next slide.
Sorry, Drew, you pass it over to me.
No,
But it's not me, it's Mary.
no,
Okay, all good.
it's
Okay,
not me.
that's good.
I'm sorry, technology issues. It's not changing. I'm going to stop sharing for a moment.
We can see it now.
Okay, great. Now Mary's like the focal point of the
Oh
dashboard.
my gosh, I'm
No,
so
that's cool.
sorry.
That's good. No problems.
We don't use just for the record. We use Teams here on campus. We use Zoom very infrequently.
Mary,
That's
that
all right.
that view that you have now looks really good because you're out of the picture and you can still see the slide full. It's perfect.
Yeah, it's
Yeah,
perfect.
Oh my gosh, sorry.
it works, Mary. You're the focal point now. We'll just get
I
Scott
don't
down
want
there
to
and there,
be.
and then the two of you are like
I
the
can't even
pioneers of
see.
this program. It would work out perfect. We should take a screenshot. Anyways, so that being said, it was how do we get people involved? How do we get that knowledge out there? How do we show people what we're doing? And this was that vehicle that we were going to use. And this is just one of the examples of the public facing dashboards, this dynamic Sankey that shows exactly what our district energy system does and how we use it. So as you can see, it's quite complex. The natural gas comes into the cogen plant. We then use that byproduct heat or the natural gas into the cogen, which feeds the generators. You can see the electricity being generated by the generators, which is in the measurements of gigajoules. And then you can see how many engines are running at one time. So there's 1, 2, 3, and 4. 3 and 4 are running, right? We have that thermal storage where you can see if the thermal storage was discharging or charging at that time. We have that 1,000-ton absorption chiller, so you can see how the heat makes that chilled water, and then you can see that transition of chilled water to the campus. And then there's an electric chiller. So this must be a screenshot from the wintertime where we weren't using that much cooling, or shoulder season where we would have been using the absorber. So excellent, an excellent way to showcase what we're doing. And then we added, on top of that, we thought, you know what, people might not know the measurements that we use, like BTUs, gigajoules. So we thought we would get some fun facts out there, like, so whatever energy we were producing, it would give you the number of homes heated annually, powered annually, and passenger vehicles on the road. And you can see in the lower corner, you can see how many megawatts we're purchasing and generating and combined. So the combined consumption at that time was 5.9 megawatts. And then just for the average person, just to get them to look on the way by, we put the ticker there because everyone wants to know what the weather's like during the day. So we have the banner on the bottom, and we've had so much so many questions coming up about the dashboard, and so much enthusiasm and so much momentum since we put that there. We were doing 1 to 2 campus tunnel tours a year. Now we're doing 1 to 2 a month. So we're really getting buy-in from Brock University and the campus just because of this. Next slide. Perfect. So the next layer for this to really try to engage our campus community was the EcoBoss challenges. Scott, myself, and Mary, we were trying to figure out how we could engage the public into competitions and get them to participate. Ultimately, the goal is we're trying to create a lifestyle at Brock University, that sustainable lifestyle. So when you're on Brock, there's that certain lifestyle, how we want you to operate, and really just how we want you to live at Brock, and try to create momentum through sustainability for that lifestyle. So it had to be it had to be through a mobile app. No one's using their desktop. It's all got to be by phone, especially students. Like I got kids at home, they're glued to their phones. If you want anyone to pay attention to anything, it's got to be on the phone, and that's how you're going to get their attention and keep them participating on the daily basis. So what would happen in a competition was we have 5 to 6 competitions annually. My favorite competition, because it engages mostly students or all students, is our O-Week start of the year sustainability challenge. We've had over 350 students annually participating in this challenge. We give prizes away like iPads, Apple Watches, AirPods, and then like gift certificates and things like that. So these students will compete for a week from Monday at 6 a.m. till Friday at noon, and they get points. And you can't see the app, but there's sustainable actions like air drying your clothes. So there's air drying there, using less water, recycling, eating organic, walking outside, ride sharing, and you get points accumulating for that. So what happens is you get these significant savings through the week. As you can see here, like you get 15.6 thousand kilograms in CO2 savings. You get a thousand kilograms of waste diverted. You've saved 123,000 liters of water. And this is just on a week scale. Can you imagine this happening on our campus 365 days a year? Now you're talking some serious numbers that are going to make significant change. So we really have bought into this. We've done residence challenge. We have a holiday sustainability challenge, which is a team challenge. And it just makes it more fun, brings everyone together, and we're all going for a common goal, which is good for the campus. Next slide. And this is just a dashboard that reflects the competition. No one likes seeing their name better than on the leaderboard at the top. So we have a top 5 leaderboard there. You can see the leaders and what they've done. It has the pictures on the bottom. People take pictures. You get more points for that, showing, what they're eating, air drying, how air drying their laundry and walking outside. So it's really showcasing what they're doing. You can see the amount of like reusable bottles, turning off the lights, water off while brushing, recycling, shutting the blinds. You can see these actions and I don't know what time of the competition it was at, but midweek probably. And you can see how many times this action was used. So again, just a real great way to connect with your campus, connect with your community, and really try the hope is that they're going to adopt some of these habits and then carry these habits on throughout the school year, thus helping us out on the bottom end, which is our utilities and sustainability. Next slide. So when it all comes together, so you take what Scott said with the plant, you take our network security, you take, I think it's SCADA's next. And then you got the EMS, and then you got the BAS, and then you got this high performance vehicle that you're able to use all the time and creating those results that you need. And it just looks great. Next slide. So then the most recent and exciting project that we've done to date, our team, like Scott, Mary, and myself, we're really striving to be leaders in this field. Not to mention, like, for the Black Pack, we won the Clean 50 award. We've had many universities come to our campus and see what we're doing, and really they're showing interest. I think there's some universities that have actually taken the Black Pack on in the dashboards. I forgot to mention that. So we really feel fortunate that people are buying into what we're doing, and some of the ideas we're trying to create. With the electrification, this is just another example of Brock trying to push forward to their carbon reduction goals. With the district energy system, Scott and Mary tasked me with, reducing our carbon footprint. How are we going to get to 75% reduction by 2030? When you're running a natural gas fired plant that heats and chills the whole campus, there's not many, and it's the heart. You have to find other means to do so. Scott was talking about the campus being fully electric back in 1964. So that meant that there was electric boilers in each of these buildings, which worked as standalone systems. What we did was we have now got those electric boilers up and running again, but we've directly fed them into the supply lines of the district loop, and now they're supplying the heat electrically to the district loop and heating the campus. Not only does this, take away the natural gas consumption from our main emitter, lowering it to where we need to be. This whole project has taken us to a 67 to 68% reduction in carbon. So really getting us close to our carbon goal in 2030. So a significant charge in that regard. But it's also created resiliency. I can't tell you how many times that unfortunately, the plant would go down, and then I was in this oh my moment where I didn't know what I was going to do. And if it's January and -30, there's a lot of pressure to get that system back up and running because there's no other means of heating the campus, and you're not wanting the pipes to freeze and burst. So having this the electric boilers to be able as a support mechanism in order to do that really creates that resiliency, flexibility, and versatility that you need when you're a district energy manager to run and optimize your operation, make it most effective and efficient as you can. So these were the areas. The DQ Residence has an electric boiler. Welsh Hall had the electric boiler. Thistle Complex. All these areas had electric boilers that are now supporting the district loop along with the cogen. So just it wasn't just an electric boilers that we were reinventing. We also installed heat pumps, piping changes, the sophistication in the controls. I can't even begin to tell you how proud I am of our controls team and the contractors that we have and how they built this. The engineers who designed this, they're next level. Super impressed. And just we're running it now. We have made substantial completion, and our campus demand has dropped because of this. The VFDs and we have VFDs on all our major pumps now, and we also have a battery energy storage system. So we're checking a lot of boxes when it comes to district energy and support mechanisms to feed that system, giving us a lot of options. Next slide. Back to Mary.
So with the electrification, we managed to reduce our carbon emissions by 67% by the time that the project is completely optimized and deployed. But not only that, Drew already alluded to the resiliency, the flexibility. We're also planning to use it as part of our Campus as a Living Lab initiative, where we're planning to bring our brand new engineering program students to learn about thermodynamics, district energy, and to really do projects. They can do data mining, they can do machine learning, and all kinds of opportunities that this project has also opened for our teaching and research missions. At the same time, we are addressing deferred capital renewal and maintenance because we're both revitalizing existing assets, but we're also replacing assets that were beyond their useful life. Those older boilers, we're now replacing them with brand new ones. So really that's a huge difference, and that has made a significant improvement in our facility condition index on the central plant. We also are able to better utilize assets that were stranded before. We had buses and transformers that were significantly underused, and now we're making a good and much better use of all of those. It was not an easy path. It was not extremely expensive either. So the project cost was 6.5 million, and 48% of that was provided by Environment and Climate Change Canada via the Low Carbon Economy Fund. We were lucky enough to be one of the very few institutions across Canada to get funded from that project. Scott and I, we even had a phone call with ECCC because they were so impressed like how most of the people that were funded were industry and they were manufacturing. So we were the odd ones, but it was really leveraging on those existing assets and this existing infrastructure that we had, and then leveraging that with our own funds that we were able to have a very, very low cost for carbon reduction for that amount of money. The timeline was also a challenge because we submitted the expression of interest in the fall of 2021. Then we submitted the proposal in February 2022. So you can see how the timeline really moved very, very quickly. The contract signing is always back and forth between lawyers. So that was signed in 2023. It was until then, when we had a fully executed contract, that we were able to actually issue POs, get things really going. So that put a lot of pressure on the project. Drew was a project manager on the project, and throughout the whole process, it was never stopping, and just to keep thinking of possible challenges and how to mitigate them before they happen. One of the biggest ones was major equipment. The deliveries were massive BFDs, the boilers, heat recovery chillers, the heat pump, everything was taking forever to be delivered. So we had to procure those ahead of time so that we would have them deliver basically right on time or just in time. We were feeling like Toyota, right on time. And everything worked out. It took a lot of coordination and effort, but ultimately now our mechanical rooms and look like this. So that's some of the equipment that was installed once it was completed, and we have new equipment, we have new boilers, and you can tell from just the piping itself how new it looks, and just the spaces. We're really also pushing our spaces in the mechanical rooms to the breaking point, really. But it's all been worthwhile. We're very proud of this project. So I mentioned briefly campus as a living lab. This is some of the photos we figured it would make a little bit more clear what we do with this. So those are some of our students from the Masters in Environment and Sustainability, and they used Brock as a case study for one of their projects. They came up with great recommendations on how we could strengthen our sustainability process and program. And we actually managed to get that in front of the board. So it was not only realistic, it's something that the board got to see as well, and we were able to act on that. Scott has been lobbying on those fronts for us, and he has really pushed the program forward. He also started some tours in the Karen's building. That's one of it's the most energy intensive building. It's a high-end research building. So we reintroduced some of those tours that he had been doing almost a decade ago. So we revived those too, and there you see John Clutterbuck. He's a facility manager, and he has 24 people that walk through the mechanical rooms that they don't really get to see what the buildings do and how they operate behind closed doors. And that's very much in line to what Drew was talking about before. We need to get people involved, from the students doing projects in the campus as part of their curriculums, but also our own facilities management staff. Everyone is part of the solution, and we really need to make sure that we have alternatives to engage them all. For lessons learned, there's a lot of them. We had to only choose a few, but certainly it's technology and innovation can be scary, but there's a very good case to be made to trying new things and putting up with the hurdles of innovation. It really does pay off. You have to manage it carefully, but it's worthwhile. Also, you need to have the right partners involved. You want them to be your consultants, your engineers, but you also want them to be your students. You want it to be your senior leadership, because without Scott and the support of the board, we would have never gotten this far. So you need really partners and champions everywhere. And also, it takes time to build a comprehensive solution. It may seem we didn't want to portray, we did an electrification project, we just replaced like for like. No, that it has been really a full process that we have followed that stems really from that. When it catapulted to success was really the Deep 1 and Deep 2 projects when the plant modernization occurred. And what's next? We're not stopping there. So we have achieved 67%, or we're on track to do that, but now we have a goal of 75% by 2030. So we still have a gap there that we have to complete. And we have some exciting ideas that are coming down the line for that. We have to reduce our energy consumption even further. And Scott and I have been working for almost a year now in ways that we can reduce that and address deferred capital renewal and maintenance. So stay tuned for those. Those peripheral energy retrofits, we're looking now more into a distributed generation approach. How can the buildings help themselves and be more efficient, reuse their own waste heat and waste resources? But it's not all about energy. We also want to advance our waste reduction and diversion. We want to continue doing recommissioning to existing systems, make sure that they are always operating the way that they were supposed to be. And of course, we want to make sure that we continue embedding education and engagement throughout the whole process, and everything that we do, whatever is next, we will make sure that we continue that education and engagement at Brock and beyond. And this presentation is part of those efforts, and we really appreciate your interest in hearing what we have done lately.
What I
And
just
we
want to
will
add
be-
there, Mary, is we threw a whole bunch of information at you and a whole bunch of slides, and of course focused on a journey we're on over the last almost coming up on 10 years of significant carbon reduction, and of course the ECCC project only being 24 months of that 10-year process to give you a snapshot. But whether you're a small campus or small site, you can take components of this, or if you're a massive campus, then this project would just be a piece of your campus. What I'd like to say to the team all the time is no stone unturned. So trying to figure out all those opportunities, all those funding opportunities, especially when universities, or if you're even in healthcare, whatever sector you're in, the competition for capital funds is fierce. Investing in stuff that's technically already working today doesn't necessarily make it to the top of the list. So whenever you can find partners in funding, federal, provincial, whatever grant there is, even a small percentage can just drive that business case a little bit further to your board. Again, we report to a board and we report to Senate. So we keep Senate up to date too on the academic side on how this impacts their research and their teaching spaces and all of that. So again, a whole lot of information in a short amount of time, but I see the questions rolling in the chat, Donald, so I'll stop there.
No, I mean, it's an amazing project. Congratulations on pulling this off. You're actually reducing your emissions by 68%, which is just an extraordinary feat. And yes, there's lots of questions coming in through the queue. I did have one question. You say recommissioning the boilers, electric boilers in those buildings. They must be quite old. Are they still just able to just start up? Are they that resilient?
Yeah, well, I think Drew can take on a lot of those questions specifically, but we've always kept some of them online. Some of the key components in those old buildings, we've actually used as a contingency plan when plant is down for circulation. So the trades have actually replaced elements over the years to keep the bank of resistive heating still working in those units. So some of them were able to come back on. Some of them, for example, their electrical infrastructure, the contactors and breakers associated with them, all well past their end of life and needed to be replaced. And others, a complete retrofit of the boiler itself, and of course the heat pumps.
You hit it dead on, Scott. Like all the components behind the infrastructure behind the boilers was all existing. We did replace most of the boilers except for the tower boiler because we did refurbish it at one point in time. So there was no point in replacing it because it was all brand new elements and everything along those lines. But this project wouldn't have been possible if Brock didn't, like Scott said, it comes full circle. Like we wouldn't have been able to do what we did if the infrastructure wasn't in place, because it would have been too expensive to have put all that electrical infrastructure in behind it. So there's a lot to say about using your existing infrastructure and trying to make the most of what you have before you install new. So yeah, that was the train of thought behind the boilers.
Just
Totally makes sense.
Questions in the chat. Drew, if you want to take the two battery questions and go together, but where did the capital funding come from for this project? What we're able to do, and not everybody's able to do this, our annual capital framework in the fiscal framework of the university is extremely small, $6 million a year on $1.7 billion in assets. So that ratio right off the bat, I could complain to the preach to the choir here too on the challenge of that ratio, but is use utility savings on a flatline utility budget to be a catalyst for the next project where we're allowed to do some of that. So take some utility savings out of an operating year, roll it into a project account and reuse that. We've been able to work with the CFO on that to drive. And then again, this project only had 2.8 million in matching funding. So pretty easy to do from that perspective on that scale. There's a question, integrate backup generator. Great question. The engines actually can operate as a backup. So we can operate 100% off the grid, the utility grid, and we have two feeds so we have an A feed and B feed from the utility. Both will run the entire campus, and we have an auto transfer scheme on that operates about 100 millisecond delay. We also can operate 100% on the cogen. So we can turn off both utility lines. So with that flexibility and integrate it with synchronized transferring across all three, we have a very resilient system. Now, If something goes wrong with the engines, they do have a backup system we call black start scenario, where the units are able to fire up and run a black start MCC that fires the whole plant up. But on top of that, we also have emergency diesel generator for life safety. We like to separate life safety and emergency, because sometimes in universities it's fairly straightforward, in hospitals, but you kind of confuse those two together. We like to try to keep that CSA code for life safety isolated. Like example, in our bioscience building, we have a small life safety generator satisfy code, but then we have a big backup generator to satisfy systems with a long ramp up time. So you're in, of course, your code, bring online in 10 seconds for that life safety on a small unit. But our large unit for that bioscience building, for example, is a 90-second ramp up time and 120-second phase transfer. So there's a whole bunch of complications. Are you there? Frozen?
I think he's on mute.
Am I on mute?
Nope, you're good.
Oh,
Yes.
Don,
There,
Thank you.
Donald is on mute. There you go.
or maybe we're running over time.
No, not at all. No, we're actually, we have some time to go through some more of these questions, and there's a lot of them. We may not get through them all, but I'm sure afterwards we can follow up. I think there was there a battery question? Was that,
I saw two battery questions.
yeah. And I guess Drew, maybe you have the handle on the battery.
What were the questions?
Yeah, so the battery question, Drew, was the size of the battery system,
So it's a 500 kilowatt hour battery.
which makes up about a quarter of an engine, just to put it in perspective.
Yeah, do you want to maybe explain, Scott, like why we had to do that? Just part of the
Yes.
project? That'd be great.
Well, actually, you can explain that, Drew,
Are you sure?
because you lived and breathed it.
Yeah. So, you know, when we were trying to get our carbon reduction target down, we were really aggressive with reducing our natural gas consumption. What happens is Scott's done a great job at kind of detailing how the campus goes. We have 2 feeders actually for on our campus. In the event of a power interruption on our main feeder, the campus will switch non-critical buildings to the second feeder. However, our lab research intensive and science buildings with all the expensive equipment do not like power interruption, no delays. So we island the plant to have no interruption for those buildings. The campus load, the critical load, is over 2 megawatts. So we run 2 engines all the time. Being aggressive, we want to run 1 engine all the time now because we have enough heat and capacity to heat the campus from our satellite assets now. What we needed to do was we had to replace that critical load feed to support that engine, and that's where the battery came in. So now, between the battery and between the 1 engine running, we can meet that critical load, and then the engines, after the power interruption, they'll go into an auto stop and start and then bring another engine on to support that load during this outage, and then we'll go back to normal operation where the battery's there to support the 1 engine. So it's just that battery was installed as a just in case, just to get us through a power outage when it does happen, so we can shut down 1 engine and we're strictly running 1 engine all the time.
What's the chemistry? Is it lithium ion or lead acid?
It's
The battery.
lithium ion, if I'm not mistaken. I'm
Yes,
pretty
it
sure.
is.
Yeah.
Okay, excellent, cool. And I think that answers the question, did you integrate backup generator into the project? I mean, you have lots of different sources.
Yeah. We're a diverse district energy system. Like, I don't know. I feel very lucky to be part of it. Scott and the team really did a great job at handing over I took over when the deep retrofit was finished. So I got a whole bunch of brand new toys, and I was able to learn with the new system. And there's a lot of resiliency with that. So it saved me a lot of headaches.
Excellent. Yeah. Bonnie, you mentioned that McEwen is getting battery storage. Is it something similar? Is it for, if you want to come online, is it for backup? kind of similar, or is
Hi.
it just for fun? Hey, Bonnie.
Hi. Yeah. No, we won an award with EcoTrust Alberta for the I think it's a decarbonization or a clean energy innovation. And so we are installing a backup battery to enable us to participate in Alberta's operating reserve program. We want to be able to shed our load. I think it's 500 megawatts. And then, so we are looking at installing a battery, installing 2 new fast chargers as well. And then we want to program that in with our current electrical panel system so that we can go down and participate operating reserves and also work on peak load shaving.
Perfect. And does your battery and setup give you that same opportunity, Brock? Is there demand charges that you can avoid peak shaving that you do with
So,
your approach?
yeah, a little bit different. I mean, every campus, every site can do something a little bit different as it relates to demand response. Of course, I'd love to be in Alberta's electricity market, but we're in Ontario, and those in Ontario on the call, the IESO, it's extremely complex market. But we do chase the peak, similar in that case. But we do that with electricity production through our engines. So the battery kind of complements that a little bit, helps us ride through a little bit, but only 500 kW. It's not long. When you're kind of predicting a peak at 4 o'clock, you ramp up at 2 o'clock and ride through to 6 o'clock. So it ends up being, 4 hours of avoidance trying to figure out where that's going to be. So we mainly use the engines in full production during those peak chasing times, as we like to call them here in Ontario.
Perfect. No, that makes sense.
The
And I
one
think,
in-
yeah, everyone's looking for ways to do that, and you're right, that it depends on your market.
It's important to be that in Ontario, that Class A customer, so that we can actually get that ultra low cost, or again, very complex to go in the market about GA costs and how that affects what's going on in the portfolio. But it helps in the winter when we're bringing on those heat pumps and buying electricity at a discounted rate to drive that efficiency. One question there to answer that's related to heat pumps and the distribution system was the temperature of our distribution loop. It's 180 degrees Fahrenheit right now. We're working on changing coil sizing and building, like I'm in 1964, to get down to the 120 range. And the team has more aggressive numbers than that at times that we'd like to dream about. But with that, we're still managing the old buildings. So the question in there was about cold climate resiliency. And the only thing I can say about that without diving too deep again, taking up too much time, is just diversification. If you're 100% electric with one utility line, wow, you have some trouble if you have an ice storm and a long power outage. And if you're diesel, depending on your jurisdiction, again, you're allowed, in some jurisdictions, we're allowed to use natural gas as a backup. We've seen where there's been extended outages when you're diesel only and your tanks are running out and you don't have anybody to come and refill them. If you're natural gas, you're able to run longer. Historically, again, there's controversy over what if the natural gas line is turned off. But again, that's all based on your local jurisdiction and what they'll allow for the CSA code related to life safety. But we've had a great experience with natural gas fired units, but again, you have that ramp up time versus diesel, which gives you that 10 seconds online a lot easier than a natural gas unit. But it's getting into some another topic.
I think Dave Cano had a question there. What were the biggest challenges you faced when implementing the energy management system and electrification project? You gonna take that one off, or do you?
I think Mary, or
Mary, you gonna take that one off? Is that a good one for you?
If I have to pick just with the energy management system, I would say it was the IT component. Luckily, we work with ITS and we engaged them early, and we went through several iterations where we looked into communicating and transferring the data via even cellular networks, which was massively expensive. But probably that was the biggest component, because everything else was already established with the SCADA system and the BAS and where the data was coming from. So all of that was already taken care of. It was more about the transmitting that data that was the issue. And on the electrification project, that one I'll pass back to Drew. He was a project manager and he was the one running around.
Well, ultimately with the electrification project, we went a full 180 from what we're used to operating. you know, we were used to the heart of the campus being the central plant. And now we're looking to our satellite assets, right? So as the feeder to that heart now. So when you are switching things up and when people are getting they're accustomed to the way things are normally run, it's really hard to create that buy-in and get people out of their comfort zone to adopt these new strategies and implement these new strategies and buy into it. There's some headwinds involving that. So the best thing you can do is just be fully transparent that this isn't going to be an easy journey. You're going to have my full support. I'm going to give you all the information you need. We're going to give the training that you need, and really just try to create that buy-in with your team. And if you can create that buy-in with your team and get them on board, that's really going to be the most successful strategy you can have. So that right now, that's what I'm dealing with. So that's how I can speak to it. It is really just the challenge of just creating that buy-in. There's going to be challenges. So just getting through those challenges and trying to make them as easy as possible. And that's really the recipe for that success there.
The best
Thanks for the
question ever just came in for you, Drew. I love it. Sorry.
Oh boy.
We like to have a lot of fun here, so we laugh with the JCI breakup. Painful. I don't get a Christmas card from JCI anymore. It's funny. But do you want to take that one, Drew?
Yeah, it to be honest with you, it really wasn't painful. It was just we had it like everything goes full circle again. And Scott couldn't have said it more right. Like in 1992, it's just technology comes out of date, and it wasn't that we were disappointed with JCI. It wasn't that we had a bad relationship with them. It really just came to a point where we had an existing Johnson legacy system. We put in the plant. And then, unfortunately, the plant technology in 2018 was not compatible with the JCI technology from 1992. So at that point in time, we had to make a decision on what's going to be the next BAS and SIS platforms we're going to use at Brock University. So we had options. So when you have options, you're gonna go back to the start. Like see what your needs are and then make the best informed decision of what you can. And that's exactly what Scott and Mary and myself did. We went away from a BAS in the cogen, and Mary, her suggestion was, let's put in a SCADA system because it's a data-driven entity. So like let's take the information from that. It was super smart decision, because then we were able to build on top of that and go from there. We went to Niagara Tritium platform only because of the openness. Our communication was OPC, so it was open communication protocol. We were FOX-S, and then we came up with a design where we could go Facility Explorer. So not only could we have the existing Johnson systems and not get rid of all the field devices downstream, we could then take those systems, use Facility Explorer JASIS, and then communicate with that as a gateway going up to our platform, which is Niagara. Go ahead, yeah.
I just want to interject there because again, there will be people who are experts on BAS on this call, know way more than I do about it. And then there will be people who are just managing portfolios. So we have the, full gamut here. And I would just want to say that just what Drew hit on there is about open protocol. Don't allow your consultants to come in and design a project for you and just copy and paste something from the last project that involves a spec about a specific manufacturer's protocol. Demand open protocol for your projects if you can. And that's where we had to shift, because once you're locked into a big company and stuck with their stuff and stuck with their generational updates, that's proprietary and you're not without a lot of dollars. And there's a lot of people doing it, better than Brock. But again, if you want to ask us a question, Drew's happy to share kind of the open protocol structure we've done. But very important point, Drew, I just want to emphasize for the whole group.
No, it's fantastic. And like, a lot of universities, if people know how procurement works, we have to allow everyone to bid and try to get award our jobs. So when you're proprietary, that becomes a problem. So Brock's procurement was very, very happy that we were opening up the competition and allowing bids to come in for different types of projects and follow the procurement protocol that is needed at Brock University. Thanks for the question.
Yeah, excellent question. Great answers. Vanette asked a question. I think maybe we've addressed it to some degree, but basically the benefits of the project must have been quantified at the start. How were they measured and assessed prior to making the investment and securing that large scale or the buy-in for the whole project? Was that tough? And was it that part of it you know?
No, pretty easy. We're creating that baseline, right? So what we did was we took a baseline from 2019. So everything was based off of 2019 data. You create that baseline, and then any projects that we were doing above and beyond that baseline, we're going to see those improvements in how we're doing. And let's be honest, sometimes it isn't that good. Sometimes we're not always the best, but in a lot of ways we are. So it really is a good gauge with how you do things. Is just you create a baseline, which is reflecting your normal day operation, business as usual. And then when you're incorporating these projects, they're going to show you how you're doing when they're implemented, and then it'll show you your payoff and everything along those lines. Right? Is that good, Mary?
Yeah, and I think that also that it became such an easy conversation, well, easy conversation. It's because we were also addressing deferred capital renewal and maintenance. We were also adding resilience. There were other benefits that were put as part of the business case that when it was presented to exec, then it was like, oh, why not do it? And I remember that was exactly the question from our CFO. We said, well, why wouldn't we do this? This looks great. And I think we're losing Scott, but I would also say that just to secure the buy-in for such a large scale project, you need a champion. And Scott sitting in that seat, he has been the champion for a lot of these initiatives. He has brought awareness to the board, to the executive team, and that has really helped us to advance things much, much faster and open a lot of doors and put our foot to the door. So I think it is important to work with your senior leadership to make sure that they understand what the benefits are, the challenges, and that they are behind you and that they champion your initiatives, because it does make a huge difference.
Absolutely. No, excellent. And I would say while it's having enormous impacts, the cost is pretty reasonable. I've heard of similar projects that cost much, much more. So you're able to take advantage of what exists there. I think that answers all the questions that have come in, and we're seeing a few people dropping off. What we often like to do, but again, yeah, thanks very much for this. It's been outstanding. It's an outstanding project. You guys really have to be commended for bringing this off, for finding the path through. It all sounds so obvious once it's all done, but you made a lot of difficult decisions and really made it all happen and worked extremely hard. So yeah, congratulations, and thanks for being available to talk to the group. There's great engagement. We're all excited about it. What we often do at the end of our meetings, and we do have some time, is go to breakout rooms, and then folks can kind of talk a little bit for a few minutes. And I am going to try to set that up so that we can do that a bit. And basically just to introduce yourselves, and I'll give you 10 minutes for it, and if you're available, that's great. And maybe a project that you're working on that's interesting. And that would be greatly appreciated.